So it's 5 o'clock. I guess we can start.
Yes, let's go.
Let's go. Okay, so I'm Alison Davey. I'm a developer advocate at Tinybird. And today we're going to see how to add real-time customization to your application or website.
Hi, this is Raul, one of the founders at Tinybird. I have been always involved in data-intensive platforms, and at Tinybird, I have been working in the development of the product from the very beginning, and I run the technical office right now. So if at any moment you have any questions, just throw it in the chat, and we will try to reply to you as we go.
Okay, so quick reminder about what Tinybird does. Tinybird helps data teams deliver real-time answers at scale through analytical API endpoints, built in minutes, not weeks. And today we're looking at how to personalize the experience for your users. Why are we doing that? Basically because that's what customers now expect. It improves customer outcomes. And Tinybird is helping to deliver this for our customers right now. If you look at the hotel's network, you can see that on their website that they're using predictive personalization to offer each guest a unique user experience. So this is the idea we're working towards today. Today's challenge is to change your website or app in real time as a response to events elsewhere or on the website. And we're aiming to do 3 things. The first thing is to change the order of images on the website in response to real-time sales. Second is to change the order in response to real-time clicks. But overall, it's to show how easy it is to use Tinybird. So let's have a look at what we're trying to achieve. Okay, so here we have just a simple app in Observable that shows we're looking at UK personalization by calling an API endpoint. Here we have 4 images, top left, number 1, bottom right, number 4. And we can see that by going through the time, we'll be moving the images around the screen in function of the data. We're not doing it for F1 teams, even though Tinybird is a big fan of cars. We're doing it for products such as shoes.
So for you to understand what is going on, every time we slide the component, we make requests that will bring data from the Tinybird platform, and will sort the products in this case, or the Formula One teams in the previous scenario, and we'll sort them based on the activity, in this case, the number of sales.
Yeah, and here all this app is doing is sending a query to an API endpoint and displaying the images. We move through the hour of ingesting data. You can see that the green image moves up and the red image moves down for shirts and for shoes. Okay, so that's the idea of what we're trying to achieve. But we're not going to do it with an observable app. We're going to do it with a website. Let me just show you what I mean.
So this is a website where your customers will be like browsing for products, and usually they will get a rank based on the number of sales, but sometimes that doesn't make sense, or you want to have a more personalized content. And here what is happening at the same time, the user clicks, you can see some clicks, you can hear the clicks, and once the data refreshes, the product with more clicks appears on the top of the list.
So we're going to build this website using a branch of Vercel's starter kit for e-commerce sites. They provide this kit to Next.js developers so they can clone, deploy, and fully customize their own store. If you're a Vercel user, do check out Vercel Analytics, which is powered by Tinybird. So on this website, we're going to have the option to reorder images based on real-time sales or on clicks. And it's a very simple example because I want it to be very understandable. But what we're trying to demonstrate is that you're getting signals from your streaming data. You can analyze those signals, and then you can react in real time. And it's up to you what events you record from your website. It's up to you what external data you ingest. The important thing is that you can act quickly. So the result is unique, personalized content. Okay, so what are we going to cover today? We're going to cover five topics. Ingestion of sales using our high-frequency events endpoint, ingestion of data from the UI, building an endpoint of rankings, then sending queries and updating the website, and finally observing statistics for the endpoint performance. What data we're going to use? We're going to use some data from a recent Kaggle competition, H&M personalized fashion recommendations, simply so that we have a nice distribution of sales and some typical dimension tables. We're going to ingest some 32 million sales events. It normally takes about an hour. And we're going to compress all the sales into the time it takes to ingest this data. We're making it real time by adding the current timestamp. So it's as if the sales were happening now. This data has no personal information. They're not real prices. We're just demonstrating the process. So don't take the data too seriously. Okay, so we're going to recap. We're handling fast and frequent ingestion of data, fast and frequent queries from a website, and we're customizing our e-commerce store. Any questions? Just ask in the chat, and we'll be happy to help. The first thing we need to look at is ingestion of sales data using our events endpoint. Let's go over to...
So the idea behind the high-frequency ingestion of events endpoint is that you can send data either from the browser because you don't want to go through a proxy or through your backend and you want to skip that, but you could also send these events from your backend, or imagine as a replacement for a Kafka topic. If you have Kafka in your installation, you could skip using Kafka just to send the data straight away to Tinybird platform.
But before we start that, we're going to create a new workspace in Tinybird. So go to our dashboard, and the first thing we need to do is create a workspace.
So a workspace, Tinybird is a way to organize your different products or your different environments. So imagine that you could have a workspace for your staging environment, for your development environment, and for your production environment. But you could also have different products within your company or your product, like a dashboard for the internal users or a dashboard for your actual customers. You could organize those different products with different workspaces.
Okay, so here we have an empty workspace. We have no data sources, no pipes. What we do have is an authorization token. And we need this token in a minute. So this is the admin token for this workspace. We'll just make a copy. And then we'll leave behind the user interface and we'll go and work in our CLI.
Okay, I am taking advantage a bit right now while Alison continues. So a token at Tinybird is behind the scenes is a JSON web token. So it handles the authentication and authorization of the request that you do to the Tinybird platform. And you can code extra information like, okay, I want this token to just access rows matching this criteria, or you could just say, okay, I want this token to just access this data source or this endpoint. You will see that later in the process as Alison will create a specific token with specific permissions for the application that we are building.
Okay, so now we're in a terminal, and if you type TB with Tinybird CLI installed, you can see all the commands we have. Right now, we're just going to use the command auth so that we give our token access to this workspace.
So TV is nice because it's just a thin but intelligent client for the API. So you don't have to learn too much about the API. You just need to learn about the concepts of Tinybird. Like we will talk later about pipes and endpoints and data sources. So this is kind of a nice instruction, so you don't have to type hundreds of bytes in curl or other tools to just interact with the TinyBird platform.
So what we've already created in this directory is a small file, a data source file that tells us the schema of our sales data. What we'd normally do when you work with TinyBird is explore your data in the UI, and then when you finally decided how you want to work with it, then move to the CLI. So here I know that the columns I want in my data are date, time, customer ID, article, and price. I'll give each column a data type, date, time, string, int, float, and a JSON path. The engine is the default merge tree, and the sorting key, I've chosen article ID because mainly we'll be sorting an article ID, and secondary key on date time. So this is the scheme we've already done. Sorry, go ahead.
Yeah, so some specific comments about this. Please don't close it yet. So the sorting key and the partition key is important, but not that relevant right now in the demo. But the other thing I think is really good to comment on the JSON paths and the columns and the types. So usually what happens when you have JSON or you want to ingest JSON is that the schema of the JSON is usually not that easy to put into a flat extractor because you usually have like nested components and things like that. So with using JSON path, you can express like, okay, my customer ID here is a flat object or a flat field, but you could have a nested field with customer and the ID within the customer. You could express that with the JSON path, and it will be trivial to match your JSON complex structures to TinyBird data sources.
Okay. So we've seen our data source file. Now what we're going to do is push it to our workspace. So it's just tb push, and then the name of the file.
So if you are used to things like Git, or if you are all like me, Subversion or CBS, you will see the match between tb push and git push. So tb push is a way to synchronize your local definition of the data source to the TinyBird API and synchronize the contents. So the API has already the new data source created straight away.
Okay, well, we'll do the same thing for our clicks data source. So our clicks data, sorry.
Alison, it would be probably nice if you already saw that the sales data source is already in the UI.
Sure.
So obviously there is no data because we just push the structure of the file, but we will start pushing data in here. But if you can see, the tb push just synchronize the definition of the data source from the file that Alison has in her local environment, and this is a way to also keep your project under version control, and there is always a plain test representation of your code or your data sources and pipes.
Okay, let's go back to our terminal. We want to do the same thing for our clicks data source, which is the data source that will collect the clicks from the website. This is even simpler. It just has the article ID, which is an int, and the timestamp from the website, and sorted on timestamp and article ID. So very straightforward. Okay, again, tb push. Okay, that's good to go. So back here we can see we've now got our 2 data sources. Again, this one is also empty. Right, what we want to do next is start ingesting data from our high-frequency ingestion endpoint. To do that, we'll use our script.
So the high-frequency ingestion endpoint, or the events endpoint, as we actually call it, allows you to send JSON documents or empty JSON or JSON lines, whatever flavor you usually use, and do it like, I mean, if you send like 1,000 events per second, it's okay. And it's not just that you can send one record. You will see here that we will send more than one record per event. So this is useful if you have to integrate actions from your web application, but if you have a backend and you want to buffer a bit and do less requests but with more data, you can also do that.
So the first function here is very important. This is the function that's sending the data to Tinybird. We just have the parameters of the name of the data source, our authorization token. We're telling it not to wait, just keep on working. And then here's just a request post with the events URL and the parameters. The next function is the one where we're making mini batches of 5,000 events from a sales CSV and loading them into JSON and then sending them to Tinybird. Each message has the date time, which is the time now, the customer ID, the article ID, and a rounded price. So that's already ready to go. And now we can just run that script.
So this script is just emulating what will be for instance, your backend. So every time that in your backend you confirm the sale of a product, it will send an event to Tinybird. In this case, for showing working with a higher volume and much more data, we are actually selling 5,000 products per event that we send. But you get the idea of what you could do with this. So either sending just specific events one by one, or sending a batch of events if you have a backend or something like Kafka in front of this or something like that.
Yeah, so this script is reading a 4 GB CSV file, and it's showing you here just the first record from that file, which is a date, the customer ID, article ID, price, and sales channel. We're just using the customer ID, article ID, and price, and then we're adding our own date time. So that's running away. We can leave that in the background and go back to Tinybird. So if you look at our sales data source now, we'll see that it's already populating with the information from that script, and it's happening in real time. Okay. The next thing we want to do is look at ingesting data from the UI. All we need to do here is click on Add Data Source, and we're going to use local files. So the first local file we're going to take is our articles, and these are the 106,000 different articles available in the HMM store. We just click Add, and we're proposed, would you like these column names? Would you like these data types? And we can change them if we wish, but here we're not going to bother. But for example, you could say that something like graphical appearance doesn't need to be a string. It can be a low cardinality string. There are very few options. It doesn't need to be a string, and it can take up less space in your database. But we're just going to accept the defaults for now.
So the idea with working with data is that at the beginning you usually don't have any idea, or I mean, in some scenarios you don't have any idea what your data looks like, and you don't care about all the columns. So with this approach, we kind of solve like 95% of the problems deciding on the schema, the types and all that. We didn't show this in the CLI, in the TV command, but you can also do this with the TV command line interface. But both interfaces, the UI and the CLI, helps you to make sense of your data at the beginning if you don't know much about your data. Anyway, I think we have a question. I'm going to read it out loud and try to reply. Question: if you are capturing events from a web app, do you recommend sending them from the client directly to Tinybird or to route them through our own server? Is there any practice that you have seen? We have seen both. It depends a bit on how important it is for you to keep the data around your infrastructure, or if you plan, for instance, what we see is if you plan to send it to Tinybird, but you also want to keep it for yourself or for other purposes, you usually go through your backend. But for other kind of data, or for data that you don't plan to store it in anywhere else, it makes sense to send it directly to Tinybird. You could have just a token that has permissions to push to a specific data source, so you don't have to worry about sending through your backend to guarantee that you are sending the right data to Tinybird. So, I mean, we can talk about the specifics if you have any specific, but we have seen both, and both are legit uses of the API for capturing events.
Okay, I'm just going to add one more small file from the local CSV, which is just the shoes and the shirts we're using in this example. So we have this file simply because we're going to link to the images for these articles so that we can work with them on the website. It's a tiny file.
So the idea with this file, I mean, you could then usually do this in your production application, but is to simplify the amount of products that we use. This file will work just as a filter for just working with shirts and shoes.
Okay, so now we have all the data sources we need for this example. We have our sales data that's ingesting. We have our empty data source of clicks. We have our dimensions table of all the articles. And we have our small table for the images of shoes and shirts. So you can take a time out for the moment and just talk briefly about how Tinybird works before we move on to creating some pipes. So if we just look at the Tinybird process, we've really got three components to Tinybird. We've got the ingestion, transformation, and API endpoints. And it's fast at each stage. So the data ingestion, here we're looking today at real-time ingestion using the events endpoint, so it's very fast. The transformation, these are SQL pipes, and here it gives you the chance to do rapid prototyping, and so be fast in your development. And then finally, we have the API endpoints, which are low latency performant endpoints, so you're fast in delivering the data you need for your applications. Okay, let's go back to the UI.
Sorry, Alison, we have another question. So my other question is related to the problems of sending massive amounts of data from a web client. I have seen Google and others have a client library to optimize the process, batch send, compress, etc. Is there any plan to release a library to use a client to help on this respect? I can understand why other platforms want to do that. My answer to that is, like, right now, with the capacity that we have in this API, you could send thousands of events per second and it should not be a problem. So I don't see the need of creating a library. You might have something in mind. It would be nice to talk again about the specifics, but in this case, you will see that the script that Alison started a few time ago is sending every second like thousands of records and a few events per second. So, I mean, right now, if you want to try it, you can send like thousands events per second and it should be okay.
And that's exactly what we want to have a look at now. The first pipe we're going to create is just a very short pipe to check on the progress of our sales ingestion. So we're going to call this pipe check.
Alison, just in case, could you make the the screen, the thumb a bit bigger, or,
Yep.
yeah, or collapse.
So this is a single node pipe, and we're just going to keep an eye on how the data is ingesting.
Is the thumb, I mean, for the ones watching from the streams, is the thumb okay now? Just continue, Alison. We will get the feedback.
So we can see that the data's been ingesting now for 8 minutes, and it's ingesting at a rate of 9,400 messages per second. So that's 9,400 rows per second. Remember that each mini batch is 5,000 rows. And that in this time we've been chatting about ingestion, we've ingested 4.3 million events. So it's working fine. If we run it again, we see it's now 4.7 million. So that's our pipe running. Okay. Next we want to build our main pipe for this example, which is the ranking pipe. So we'll call this API ranking.
Okay, size is good.
Good. This has got 5 nodes, so Raul can keep chatting as I copy and paste. We'll talk to each node as we do it.
Yeah, so I'm gonna try to explain a bit what an endpoint at TinyBird is, but I'm gonna start first with a pipe. So when you start writing SQL code for defining an API that returns data to your web application, usually the first queries are quite easy and you remember what you are doing. But when the queries start to become bigger and you have to consider other cases and other scenarios and other filters, it gets complicated. So a pipe is a way to structure your different queries in smaller steps so you could make sense of them, not today, but in 3 days when you come back to see what is going on or what you need to change. So a pipe serves that purpose and also serves the purpose of making sense of your data. So you can run a query several times and change a few things and see if everything makes sense and if you are giving the right names to the columns and all that. And at the same time, it lets you structure in smaller steps, as I was saying. So here, Alison is just creating the first pipe, which is API ranking. And within a pipe, you can have different nodes. If you have used before Jupyter notebooks or the concept of notebooks, you will see that it's quite similar. You can concatenate and reference other cells or other nodes in the pipe. And on top of that, SQL is usually a very static language to represent the request of data to a database. But usually when you are building an API, you need to make it flexible and dynamic. So in TinyBird, we have a template system on top of the SQL queries that you can write. So you can see here that there is a placeholder that is called cate, meaning category. Source is the default value, and you have a description. We could see this later. The description is for the documentation that we automatically generate for the pipes and the endpoints. But in general, get just the idea of being able to later on runtime from your web application, you can send different parameters in the API endpoint request and change the behavior of your SQL on runtime.
Yeah, so this first node is just a filter for the products we're interested in for our website. The golden rule in TinyBird is always filter first, so that's what we're doing here. And the second node will be to rank our items by sales.
So meanwhile, I'm going to take care because there are more questions. Thank you for the questions. There is one which is, okay, I think yeah, this is a reply from the previous one. And getting into the specifics, devices, low connectivity regions, or using cellular data, and they could benefit from a client that supports retry, compression, or batch sending when good connectivity connection available. Yeah, for that use case, it makes all the sense to have batching and things like that. We don't support that right now. We focus on having good connectivity and working from like browsers or mobile devices with great connectivity, or backends which usually have great connectivity. It could be nice to talk to you later and trying to understand if this is web application or is low level or actual mobile phone applications developed in native code, and see we can make sense, because we already do some of these things in one of our internal libraries, so it would make sense to talk to you more into the details of that. So feel free to reach us through our support email. I don't know if Stefan is around, probably could help you with the way of contact us, or join our Slack and we can talk in our community Slack about that specific use case.
Okay, so this second node in our pipe is the sales ranking. We're just selecting the articles and a count of sales from our sales data source, the one that's ingesting in real time. We're then just making sure we're only taking the articles from our small set of products. And we're also checking that the time, so that it's below a certain time. This is for our little observable app that was changing things depending on the time. Okay, so that works. The next node is very similar, but it will be a node for the clicks.
Okay, taking advantage, there is another question. How many requests per second can we handle? It depends on the kind of part of the API that you are using. But for instance, for reading data, we have customers doing in the hundreds of requests per second right now. We have customers doing ingestion of in the millions of records per minute, 24/7. So, I mean, I don't have a specific number for your question, but you get the idea that we can handle hundreds of requests per second for reading data and thousands of or millions of events per second for ingesting data.
Okay, so this clicks ranking node is very similar to the previous one. We're counting the total number of clicks for the articles we're interested in, and then we're just making sure that it's happened in the last couple of hours. If we look at our website, we'll see that it's based on hours. And if we run this, we'll see that it has no data because we have not yet had any clicks from the site, so the clicks data source is still empty. Okay. The next node is just a quick fix in case that we have no sales or no clicks for our selected products.
So this query is a bit weird because of the way we are filtering out just the 32 articles that we want to build the application on top of it. So for your normal use case, you won't write this query actually. So no, this is just for the demo.
This node was just to make sure that if we had zeros here, they were we still had a full table. And the final node we need is our endpoint.
So when we talk about an endpoint, is what you publish as the result of the pipe, and you can query this endpoint or this pipe through that endpoint, meaning that you can now use the different parameters that we already defined. You will have metrics around that. We will see that later, but considering as a way of publishing the pipe as a API.
Okay, we're just missing a bit more from our endpoint.
Okay, there is another question. Meanwhile, regarding currency, is it possible to ingest USD dollars and have the materialized view be in different currencies? yes, and we have seen this in the past. Sometimes you want to change, and what you will do in that case, answering your question, yes, you can do that. What will you have? What you will have is another table where you have all your currencies, and you will join that table as your data arrives, and you can change the USD dollars to, I don't know, euros or something like that, or to another currency. In other scenarios, you don't want to materialize at the time of ingesting the data, the currency, and you will just do a normal join, as Alison is doing here right now. We don't constrain on doing joins or things like that. Actually, we encourage people to do joins because this is supported really well and it works with good performance. So depending on your use case, you will have to do it at the ingestion time, and other times it will be more sensible to do it on the runtime of the query. So for instance, if you are doing something like making the transformation at the end of the quarter for fiscal or for legal reasons, probably you don't want it to do it at the ingestion time. But other times it makes sense. For instance, if you are charging your customers in euros, but you are putting the price in dollars, it probably makes sense to do the exchange rate conversion at the very same time that it happens.
Okay, so getting back to our endpoint node, here we are just getting the data we need for our website, which is the part number, which is the article ID, total number of sales, product name, which we've picked up from the article's data source, the price, which we picked up from our shoes and shirts data source, and also the image, which we concatenate with the location of the image. So this gives us the final results. That's everything we need for our website. To create an endpoint, we just click Create API Endpoint. Select which node we're going to use as our endpoint, and it's done.
So in this case, what you get in return, as you can see, is a URL, which is already populated with a secure token. So this token only grants access to reading the results of this endpoint. And you can see, probably you need to, no, I think the size is okay. You can see there the start minute and the category is already pre-populated with some of the categories that are the default values. So you could make requests to this endpoint by changing the parameters in there, and you will get different results. Yeah, we need to trust that Rebecca and Delphine's. Yeah, it's a shirt. You can see it there. Yeah,
it's a shirt. Okay, so we have a token here, but this token only gives me access to read the API ranking pipe. And for our website, I also want to read and write to my clicks data source. So I need a token with a little bit more scope, and I can do that here in the UI, manage auth tokens, and I want to create a new token. I'll call my token demo. Doesn't matter what you call it. Okay, and I'll give it some scopes. So the pipe scope it needs is API ranking. It needs to be able to read that pipe. And then the data source scope it needs is to have access to clicks. It needs to be able to read clicks and append to clicks.
And in here, could you, well, it doesn't matter. I can explain it any way. In there, you could say, okay, I just want to give access to the clicks, but with these constraints. Like, for instance, only you can access clicks from the web browser Chrome or for Firefox. It doesn't make sense for this example, but you could, in the token, also put restrictions on what data you can access.
Okay, so we've copied our demo token, and now we're going to move over to working on the website. We have another terminal window. Let's see if we can make it bigger.
Yes.
Yes. Okay, so what we've already run here is MVM use 16 because we're using node version 16.14.0 for our Vercel starter kit for e-commerce websites. We've changed the directory to where I've located this repository. And now what we need to do is update our local environment with our new token. So you can see here, it previously had a token from another demo. We can get rid of that.
So for this, we are using Nest.js, which is Vercel's kind of de facto framework. And we are just populating with the token, and the application that we already have ready will pick up this token and we'll start making HTTP requests to the endpoints that we just defined. Alison will show you now.
Yeah. So just shout out to Javi Parra and Gonzalo from Tinybird, who helped adapt this demo from the normal Vercel demo to making it suitable for this live coding session. Now what we need to do is type npm run dev, apparently. And it's working. Let's go back to our browser. That didn't work. Okay, if we go to our web tools, we can see what's happening. Filter. I had too many requests,
Just reload. I mean, this is what happens when you do a demo.
Okay, I know what happened. We didn't add the token correctly. I didn't write the token. I just quit the
okay.
The thing. Let's do this again. That's what happened. Okay. Let's go back.
Happens in the best families,
Right. Let's just not change the token and leave the one that was there before. Let's put a new token in. So, okay. Let's hope this one works. And we're actually going to write the file this time. Okay. And try again.
Okay.
Now, much better. Okay, who said it was going to be live? Right. So now we're on our website, and remember that we said the sales, which you probably can't see, but I'm going to make it bigger.
Thanks for the suggestions from the public. we made it just to be sure that you were paying attention.
Thanks, Gonzalo. It's a big help. Okay, so if we auto refresh this for a moment, you'll be able to see that the numbers, you might not be able to see, but the numbers here are changing as the sales are coming in. And we have, for example, here currently 2374, and now it's changed to 2405. So as sales are ingesting, the number of sales for each shoe are changing, and the images are moving through this grid. Flip-flops are doing very badly, but our winning shoe is not yet the winner. Okay.
So when Alison says that our winning shoe is because we know that if we ingested all the data at the end, the winning shoe is the one in green. But I mean, in reality, you won't know this. In real life, it doesn't work like this. But just to be aware, for you to be aware of what we are saying when we see our winning shoe.
Okay, so we know that the images were moving as a result of the sales that are being ingested in real time. We can also look at changing the location with the clicks. We just switch to top clicks, and we can choose to click, for example, on our winning shoe.
So
Give it a few clicks.
It could be, yeah, yes, yeah.
Refresh,
Now
and it's moved.
it could be nice if you do the clicks and we have at the same time the network panel, and we can see that we are actually sending events to the events endpoint in TinyBird, and that's the thing that is actually changing the ranking.
Okay,
so
you've got to believe.
Yeah. And the idea behind this is that, yeah, usually sometimes you want to promote the content that is selling better, but sometimes you don't want to promote the products that actually selling really good because they are already selling really good. Yeah, you prefer to promote other type of content. And the idea here is that as people visit other products, we are promoting them in the ranking of your website.
So you can see all the clicks going through here and changing the thing. If we look at the calls to TinyBird, you should be able to see that this is the call with the API ranking pipe, our token that we managed to load to our local file, and then our parameters of a limited number of products and the clicks. If we switch here to top sales, we can see again, now the ranking has changed, now the ranking is sales. So this is what we wanted to achieve. We're changing our website in response to external data, our real-time ingestion of sales data, and to what's happening on the website, the clicks on the images. Very simple actions, but the idea is that you can do so much more once you define what you need. Okay. Is there anything else you want to see on the web tools?
No, that's okay. I don't know if the public want to know more, but it's okay on my side, Alison. Thank you.
Okay. We just check our sales, and look, our flip-flops aren't doing so badly, but they will in the end. Okay, I'll turn off auto refresh. Okay, so let's go back to TinyBird. And what we're going to have a look at now is our endpoint performance. So
this is what actually happens to any application that you build. Once you publish it, you want to know how it's performing and how your different components are performing. So what Alison is now displaying or is going to show is on top of the product, we have an observability layer that you can take advantage of, and you can see, as you, yeah, probably Alison, you should continue and explain what we have here.
So we can see here that the activity we've been doing in the last 5 minutes on the website has resulted in calls to the API endpoint, and we have these usage metrics. So you can see that a call processed 23 megabytes, that it took here 200 milliseconds. If you want more detail, you can click on here and see a graphic which shows exactly what's happening. You can change the granularity. So basically, we have a lot of information that you can see on what's happening with your API endpoint. You can track how much it's consuming, how long it's taking, if it's consuming too much data or it's taking too long. You know, this is the pipe that you need to think about optimizing, and then you can look to writing better SQL. Okay, so just to recap on what we've seen today, we've seen sales data being ingested in real time to organize what's appearing on the web page. We've seen changing the web page in response to what's happening on the web. And as I said before, it's a simple example, but it's to give you the idea of building this very quickly in a very flexible way with TinyBird, having the statistics on performance to sort of see exactly what you're doing. Okay, so we've seen ingestion of data from the UI, we've seen building an endpoint, we've seen observing performance. Next steps. What you should do next is go and check out the GitHub repository. Let me just share the link. Okay, And here you'll find everything you need to run this example yourself. So you can download all the data. You can load the pipes that are already written in the data project, and you can build your own website using the branch of the Vercells example that we've got on our GitHub. So basically, you can go away and do this yourself and see how easy it is to work with Tinybird. How in no time at all you can build something. So check out the repository, sign up to Tinybird. It's free to sign up to the build plan. All that we've done this afternoon you can do on the build plan. Build your data product, and then come and talk to us in the community Slack to tell us how you're going, what you like, what you don't like. Talk to us about Tinybird. Let me just share the repo. I'll learn something else.
I just shared it, I think.
Okay, good.
I think, I'm not sure.
Yeah. Okay, so what we wanted to show was how easy it is to use Tinybird, that you build your data products by ingesting data, running transformations on our cloud, and accessing the results of the endpoints. You know your business needs, and the limits to what you can build are only set by your imagination. So we have an inspirational quote, of course. Just organize myself. The only limit to your impact is your imagination and commitment, according to Tony Robbins. Here, you can use your imagination, and the commitment to the build plan is really nothing, because you don't even have to put your credit card in. Just sign up and give it a go. Okay, we have opportunity now for any questions. If there are any more questions. And if not, we can just mention that the next session will be in 2 weeks' time, where we'll be creating custom alerts using dead simple SQL. And that will be run by Javi Santana, co-founder of Tinybird, and Gonzalo Gomez, sales engineer, who helped us out today by telling us to write our file. Okay, are there any questions, any comments? Nope. Anything you want to say to wrap up?
No, that just go and wait. There will be questions. No, I was about to say that use the product, give us feedback. The most important thing for us is people using the product. So go and join our Slack as well, so we can help you in there if you need help. That's pretty much. But we have a question. Do you have any material that explains your usability feature? Not sure about that, because we recently launched that part of the product, but we can reach out to you and give you, I don't know if we have the documentation for that, because it's kind of a super UI friendly interface, but I encourage you to use the product, register, use the product, and we can talk about the observability feature if you need more information about that.
Yeah, just come along and join the community Slack. You can ask any specific question there, and people will jump straight on to give you the answers you need. All good?
Okay.
5 minutes to chat about life.
Thank you everyone that joined and join the Slack. You will have fun there talking about data and problems with data.
Cool. Thank you everyone for watching.
Thank you. Bye-bye.
Bye-bye.